In this problem, we'll use Excel to solve a quadratic application problem. The problem reads that NASA launches a rocket at t equals 0 seconds. Its height in meters is given by this quadratic function. So t is the time in seconds, h of t is the height in meters. We're first asked to find the time when the rocket splashes into the ocean, and second, we're asked to see how high above sea level it will reach, so the highest it will get. So we're going to create an input-output table and graph, and we're going to use Excel to help us identify the answers to these questions. Notice that this function is a second-degree polynomial. I notice that the leading coefficient is negative. The number in front of your t squared is negative, which tells me that the graph of this is going to be a parabola that is open down. The vertex of the parabola will be that highest point on the graph. That vertex is going to help us answer part B, the highest point that the rocket reaches. The input is t seconds, and we can start that at t equals 0. It doesn't make sense to plug in any t values that are negative because we start at 0 and then get higher. The seconds get higher and higher as time goes on. So how high should we go? Well, we don't know. At the moment, we don't know how high to go until the rocket splashes back down into the ocean, and this problem should stop the time. So we're sort of guessing, but for now we could maybe guess that since it's a rocket being launched by NASA, it'll be up in the air quite a while. I'm going to go ahead and increase my t values by 10 seconds at a time, so 10, 20, 30, and so on. I'll take it up to 100, and we can adjust that later if necessary. I then define my h of t values using the given equation. So I have my equation as negative 4.9 times the cell squared plus 310 times the cell plus 332, and then I drag that formula down. I highlight everything and I insert a smooth line graph, and there it is. It looks like an open down parabola. Now I'm going to go ahead and add labels to the input and output axis to give the real world meaning of the input axis and the output axis. Now looking at this graph, we are starting at t equals 0, 0 seconds, and it's going up, 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 all the way up on this graph. It looks like up to 120 seconds. And the heights here go all the way down 20,000 negative, that's below sea level, up to 10,000 positive. Now notice, it makes no sense to have negative heights of this rocket. We would stop the problem when the height equals 0, because that's the rocket would hit the ground and crash, or it would hit the ocean. So we really should stop right here and not consider this parabola to make sense as a model after that point. In my table, I'm going to go ahead and delete these that have negative h values. So that's a little better, and we're going to go ahead and find this point in a moment. Okay, so the first thing in part A that it asks is what time will the rocket splash into the ocean? On the graph, we're thinking about when this graph hits the height of 0. So in the equation, we need to find when h equals 0. And in the table, we need to find the point when that happens. It happens a little after 60. Notice at 60, there's a positive value of h. At 70, there's a negative value of h. So somewhere in between, it must be that the h became 0 as it crossed from positive to negative. So I'm going to use solver. So I put my cursor in the cell that's close to having an h equals 0, which is cell B8 in my case. I go to Data, Solver. I let set objective set equal to the y value that's closest to a y value of 0. I want it to equal a value of 0 by changing the x value cell. I hit solve, and this is, remember, an approximation. This is really close to 0. It's saying the y value is 0 when the input is 64.3187 approximately. What does that mean in context? It means when 64.3187 seconds have passed, the height is 0 meters above ground, so it hits the ground, or it hits the ocean. In part B, it asks to find how high above sea level the rocket will reach. So that is asking us to find the vertex of this parabola. The vertex occurs somewhere between 20 and 40 on this graph. In the table, we're looking for the point that has the highest y value, somewhere between a t value of 20 and a t value of 40. We see that in our table, cell B5 is the highest value of h, but we're going to use Solver's maximum feature to find it. I put my cursor in cell B5. I go to Data, Solver, and I click on Maximum. All right, I am putting the y value set objective set equal to cell B5 because that's closest to the maximum. It has the highest y value I can see in my table. I select maximum, and I select by changing variable cell A5. That's going to be the x value cell. When we hit solve, and it says that when the t is 31.6327 approximately, the height, h, is 5235.0612. In context, that tells us the rocket reaches its highest point, which is 5235.0612 meters, after 31.6327 seconds.